We're continuing factoring polynomials. Our goal is to factor completely, so we're going to keep factoring further and further and further until we cannot possibly factor anymore. Taking a look at example 1, this is clearly a difference of 2 cubes because x cubed would give me x cubed and 2 cubed would give me 8. So A is x and B is 2. Where it says methods, problem solving tactics right here, I want you to make a note. This is a difference of 2 cubes. We're also going to write down the rule really quick. This is going to help us try the homework assignment. So A cubed minus B cubed equals, remember, sum and difference of 2 cubes. Both start with AB in a binomial and then A squared, AB, B squared in a trinomial. The only difference is their signs. So because this is subtraction, it's minus, plus, plus. If this were addition, so a sum of 2 cubes, it would be plus, minus, plus. So going back over here, I'm going to plug my A and B value into this rule. So that means I have x minus 2 times x squared plus 2x plus 4, because x squared gives me x squared, 2 times x is 2x, and then 2 squared is 4. As I mentioned, we want to check and see if we can factor any further. Looking here, A is 1, so I can try guess and check. Guess and check means we look at the factors here, so 1 and 4, 2 and 2, and ask ourselves, is there any possible way using same signs and the factors of 4 we can get to a positive 2? The answer is no, so we are done factoring this. This is the furthest it will go. Take a look at example 2. I have an x cubed, but nothing cubed gives me 2. An indicator here, rather than saying not factorable, is maybe we should check and see if there's a greatest common factor. A lot of people forget that we always need to be checking for a GCF. So I'll say always check for GCF. This is one of the first things you should be doing. So I do recognize that there is a GCF here of 2, meaning where it says methods or problem solving tactics, the first thing we're doing is we're pulling out a GCF. Once we pull out a GCF of 2, we'll see that x cubed plus 1 remains. And we need to ask ourselves, can we factor this further? The answer is yes. This is a sum of 2 different cubes. So sum of 2 cubes. Over in the methods and problem solving tactics, I'm going to write the rule once again. Now we have a cubed plus b cubed, and I would have ab in a binomial, a squared, ab, b squared in the trinomial, and because it's plus, it would be plus minus plus for the signs. I'm going to go ahead and plug in my values for a and b then. What cubed gives me x cubed? That'd be x. What cubed would give me 1? Well, the answer to that is 1. When I factor it, I would get x plus 1. That's easy enough. X squared is x squared. 1 times x is 1x, so minus x. And then 1 squared is just 1. We do need to check and see if we can factor this any further. Because it is a equals 1, I can use guess and check. The factors of 1 are 1 and 1. Using same signs, there's no way we can get a negative 1. So we are done factoring at this point. Let's take a look at the next one, which is example 3. For example 3, we have 4 terms now. Whenever we have 4 terms, we know that we need to factor by grouping. So over where it says methods or problem solving tactics, we're going to write factoring or factor by grouping. When you factor by grouping, you pair the first 2 terms together and the last 2 terms together. Once you've done that, you need to check for a GCF. The goal is to get it the same thing in the parentheses. So when I look here, 8 and 20 are both divisible by 4, and then I want to pull out an x squared. Remember, you always pull out the lowest power. Once I pull out a 4x squared, what remains is a 2x plus 5. Now looking here at my second set of numbers, they both are divisible by 5. When I divide each term by 5, I'm left with 2x plus 5. So we do have the same thing in parentheses, meaning I can pull that out as a 2x plus 5. And in our second set of parentheses, we write what remains, so the 4x squared plus 5. We need to check and see if we can factor this any further. If this were, let's say, a difference of 2 squares, then maybe we could. However, this is a sum, and these are not 2 squares. They don't have GCFs, so we are done at this point. Example 4. Now, this may look a little bit confusing because it's v to the 4th power, but let's use what we know. Whenever we have a binomial like this, we can first off pull out a GCF, which it has none. Or we can do the sum or difference of 2 cubes. There's no way I can write this so it's cubed, but I do have one strategy left, and that would be the difference of 2 squares. Difference of 2 squares. Perfect squares. And the rule, while I'm over here actually, is if I have a squared minus b squared, and remember we went over the fact it must be subtraction, then I can rewrite it as a plus b times a minus b. If you're asking yourself what squared would give me v to the 4th power, well, that's v squared, because when you have a power to a power, we multiply. This was a property of exponents that you would have learned in Algebra 1. Minus, if you ask yourself what squared would give me 81, well, the answer is 9. So a is v squared, b is 9. I would rewrite it as v squared plus 9 and v squared minus 9. However, we are not done yet, okay? V squared plus 9 is done because this is a sum of 2 perfect squares, but here I have a difference of squares once again. So I'm going to say we're using this twice. We're using it twice because a in the v squared minus 9 would be v, and b would be a 3. So I now can write it as v squared plus 9 times v plus 3, v minus 3. This is the furthest we can go, so we actually factored it twice. Taking a look at example 5, so many people try to rewrite it and move the x cubed up front. There's no need, okay? In fact, people start making sign mistakes when we do that, because if we were to move this out front and move the plus 1 at the end, we would then have to pull out a negative GCF before being able to factor it at all. So you're going to make it more difficult on yourself. Let's go ahead and just keep it the way it is. And I want you to notice, because there's 2 terms, it's either going to be a GCF, perfect squares, or perfect cubes. So there's no GCF. I have a cube, so obviously it's not a square. But I could try a difference of 2 cubes. I'm going to write the rule off to the side. For the difference of 2 cubes, we have a squared minus b, or excuse me, a cubed minus b cubed. And I'd have a binomial with ab, a trinomial with a squared, ab, and b squared. Because it was subtraction, it is a minus plus plus. One cubed would give me 1. 2x would give me 8x cubed. Plugging this into my rule, I have a minus b, so 1 minus 2x. I know it looks a little weird, but let's just leave it like I said. And then here I would put 1 squared, which is 1, plus 1 times 2x, so that's just 2x, plus your b, so 2x being squared. Now here, you need to remember, if we're multiplying, it is okay to distribute. The only time we cannot distribute is if it's something like this, where we have addition or subtraction. So that's a no-go there. But if we're multiplying or dividing, we can distribute the power, meaning it is a 4x squared here. If I were to rewrite it and try to factor it, you would see that it does not factor any further, so this is our final answer. I want to talk about the homework really quick. If you're in my informal Algebra 2 class, you're going to skip 5, 6, 7, 8, 9, 14, and 15. My regular Algebra 2 students will complete the entire assignment. So again, only my informal Algebra 2, so my first hour and fifth hour, are allowed to skip 5 through 9, 14, and 15. I would like to model number 17 for you all. So number 17 says we want to factor the polynomial completely after using synthetic division. So far, we've been using synthetic division and saying, hey, if the remainder is 0, yes, it is a factor, and we've been using it to divide, but it can do so much more than that. If something is a factor, well, then we can use it to write it in factored form. And that's what 16 and 17 on your homework goes over. 17 says z cubed minus 6z squared plus 3z plus 10. And I gave you that the factor is, there was a typo on your homework, it should say z minus 5. If I'm going to use synthetic division, remember, we need to check and see if this is written in standard form and if we need any placeholders, which I do not need. So it's 1, negative 6, 3, and 10. To get the number that goes on the outside, we set our divisor equal to 0, so that would give me a positive 5. Bring down the first coefficient and start our pattern of multiplying, adding, multiplying, adding. So 1 times 5 is 5, negative 6 plus 5 is negative 1, negative 1 times 5 is negative 5, 3 plus negative 5 is a negative 2, negative 2 times 5 is a negative 10, 10 plus a negative 10 is a 0. So once again, see how the remainder is 0. This is a factor. So how I can rewrite it is z minus 5 times z squared minus z minus 2. Again, what I've done is I have now written it in factored form. I factored using synthetic division. This is a new idea. Once again, we've only used synthetic division to first off divide, and second off to determine if something is a remainder or not. Now we're seeing if it's a remainder, how to factor it further. So you need to put your divisor out front and your new coefficients go here 1 degree less than what we started. We do need to check, can I factor this any further? Because a is 1, I'm going to use guess and check. The factors of 2 are 1 and 2, and I must use different signs to get a negative 1. So is that possible? Yes. The 1 would have to be positive, the 2 would have to be negative. So I would rewrite my z minus 5, and the z squared minus z minus 2 becomes z plus 1 and z minus 2.